Dr. Ocobock is the director of human energenetics laboratory at Notre Dame. Her research program integrates human biology and anthropology with a focus on the interaction between anatomy, physiology, and evolution, and the environment. She explores the physiological and behavioral mechanisms necessary to cope with and adapt to the extreme climates and physical activities. Dr. Ocobock worked in northern Finland in collaboration with researchers from the University of Lapland and the University of Oulu. This project focuses on reindeer herders and highly activated cold climate populations. Her research assesses life history patterns, cold climate adaptations, and addresses potential health disparities.
Thank you so much for that wonderful introduction, Mike. I appreciate it.
And Cara, thank you so much for your time. This is unlike other episodes of Corby Connections, where we're specifically trying to get people excited about the Hesburgh Lecture in late April 2023 that you are going to be delivering on the campus of Gettysburg College. But here, there's so much. We were talking a little bit before we hit record, so much that your research interests get into that people might not even understand as part of anthropology. But I guess to start broadly, what drew you to humans at the extreme and cold weather coping mechanisms? I mean, this is some hardcore human being stuff. I didn't even know that reindeer herding was an occupation that was available to me. So another missed opportunity. But what drew you to these humans at the extreme and how they manage themselves?
Yeah, so I will go back a little bit, and this might strike a chord with some students who are listening, that when I was an undergraduate, sorry to say, at the University of Michigan, I was one of those students who came in pre-med. I'm going to be a medical doctor and, save lives and cure cancer and all of those things. And I ended up taking an anthropology course in, I think, my freshman year that, just to fulfill a social science credit that I needed to have on my transcript. And I kind of fell in love with it. It was one of these things that anthropology, as we were talking about a moment ago, is this field that people have kind of a fuzzy idea of what it means and what it is. And it turns out, very broadly, it's just the study of humans and their ancestors and cousins being non-human primates. And so anything under that umbrella counts as anthropology. And as I went along in my education, I maintained, a cellular and molecular bio major along with anthropology. And I found that human biology, which is kind of a specific part within anthropology, where you study living humans and kind of how their bodies work and how their bodies work in different conditions, was kind of perfect for me. It didn't have the stress and, sometimes upsetting nature that the world of medicine can bring in, but it allowed me to ask different questions about how human bodies respond to all this different stuff that goes on around us. And when it comes to actually humans in extreme conditions, oddly enough, it was a paper on mice that got me most interested on what happens with humans. So it's this very interesting paper from 1997 where these researchers got mice and they set them up in 4 different conditions. One where they just left the mice alone, so that was a control condition. One where they forced the mice to continuously run on a wheel until they were exhausted. One where they put mice in a cold condition until they got exhausted because they were shivering and thermoregulating so much. And one where, and I hate imagining this, they forced female mice to lactate to exhaustion. They just kept giving her baby pups and forcing her to lactate. And the whole idea was looking at how many calories these mice in these different conditions actually burn, and if there's this upper limit to how many calories somebody can actually burn. And so, obviously that might not be the most ethical thing to do with humans, that kind of study. Really difficult to get past review boards. And the opportunity came up for me to work with people in the National Outdoor Leadership School. And if you've heard of Outward Bound, it's the same kind of thing, where people go off into the wilderness for these courses that can last anywhere from a week to a year long, depending on which course they take. And so I wanted to see what happened to these people when they were taking part in these really extreme physical activities, mountaineering, hiking 20, 30 miles a day at high altitude, camping in the middle of Alaska in the dead of winter. So you have these extremes of physical activity and then these extremes of climate, which made for a kind of pseudo-natural recreation of that mouse experiment, minus the lactating. Not doing that in that study whatsoever. And so that's kind of how it started, is, that mouse study and how could I replicate something similar among humans in an ethical way? And then during that research, I found out that personally, I just like being in the cold way better than I like being in the hot kind of climate. And so once I had finished my PhD and got my first job, it was, all right, where can I go study humans in extreme cold? And where might people be interested in taking part in the kinds of studies that I do? And so, to put a terrible pun in, I cold emailed people in Norway, Sweden, and Finland that seemed to have somewhat aligning research interests as I did, particularly looking at metabolic rates, so how many calories people expend, and then how they acclimatize or adapt, depending on how long of a time scale we're talking about, to extreme cold conditions. And I was particularly interested in reindeer herders. And so across Scandinavia, you're like, what? How did you come to that? Because of course, that's where your mind goes. And feel free to stop and interrupt me at any time. I wanted people who were highly physically active. And, in today's world, that is actually a little difficult to find. But there are still pretty strong populations of reindeer herders in Scandinavia. In Sweden, for example, only the indigenous population, the Sami, are allowed to be reindeer herders, but in Norway and in Finland, anyone can be a reindeer herder. But these are people who live and work in extremely cold conditions, and they're exposed to it regularly. And it's a very physically demanding occupation. And so after those cold emails, Finland was the one that was most excited about it. And that's what started the collaboration with the University of Lapland and then eventually the University of Oulu, trying to figure out how these folks adapt and deal with not only their extreme cold climate, but one that's changing rapidly due to climate change. And we're seeing it happen live. I just spent all of February there, well above the Arctic Circle, about 300 miles or so north of the Arctic Circle in the dead of February, which is supposed to be the coldest month. And it hit 47 degrees while I was there. People were freaked out by that. And as well, they should be, as well I was. There were days I didn't wear a coat above the Arctic Circle, Patrick. These are things that are really interesting, and then also keep research questions coming up because it's this changing situation.
I would not have expected the mice study to be the reason why you went down this path. I did read that you are an avid power lifter, and now that caused me to think, well, okay, that's going to, can be an extreme sport. You're lifting very heavy weight in classic Olympic formats, the bench press, squat, maybe the clean, deadlift. Maybe that was your motivation, but it was a mice study. So that's interesting.
It does relate. So I will also admit that I am now a former power lifter. I have a pretty awful back injury that actually happened 7 years ago, but only got diagnosed 6 years ago, or I'm sorry, 1 year ago. That has taken me out of powerlifting, but it is related. So when preparing for my dissertation work, which took place in the Rocky Mountains of the United States, I knew I would have to carry all of my camping and research equipment on my back at altitude. And so to prepare for that, I hit the weight room and I hit the cardio room, and I learned I love weightlifting way more than anything else. And so when I got back from my field work, I took up powerlifting.
Yeah, well, that is okay. So now there's a connection. I'm glad that you satisfied my curiosity about that. But, all of this then eventually leads to, I think one of the categories they give you when you look at the Hesburgh Lectures, one of them had to do with sports. And so the anthropology and the sports coming together, obviously, humans at the extreme, there's a lot that can be covered here. So we were talking before we hit record about some of the questions that might be answered during your lecture. So you said, in what ways may women actually have an advantage in certain types of sports? So that's something you'll be talking about.
That is something we'll be talking about. It is, anyone goes and looks up, the differences between males and females when it comes to athletic performance, what you're going to find is the ways in which everyone thinks males have an advantage and what those advantages are. turns out females have some advantages too, but no one talks about those. So we will definitely be talking about that.
Yeah, and long before today, you and I corresponded, and I shared that if I go out for very long distance runs with my wife, any difference between men and women starts to disappear, and it's almost like she's running on fuel that I just don't have. Maybe because I'm also a few years older, but I, I've read a little bit about this too, and I can't wait to learn more. So
Yeah.
another point you made, estrogen as a performance enhancing hormone.
Yes.
Interesting.
Now, I should qualify that to some degree, only because when you think performance enhancing, you think, people doping.
Yes.
And though there are some cases where estrogen has been used as a form of doping, and we can talk about that. But I will be very much focusing on the ways that estrogen does already, in people who are not doping in any way, improve performance, and in what ways, and in what particular kinds of performance.
Fantastic. And of course, something that along these lines has been all over the news is how we address transgender athletes when they're in sports. Are they working at an unfair advantage? What is our policy on this? Policy makers are coming out with all kinds of school boards making decisions and things like that. You led me to believe that perhaps they're working with absolutely no scientific information when they make these decisions.
That's 100% true, that we do not have the data to base any sort of legislation right now at this point. And as I'll talk about come late April, that data is going to be difficult to get. But enacting legislation that actively causes harm without there being a scientific basis for it, that's bad policy.
Right. And unless I either misheard you or am intentionally misstating what you said, Notre Dame is beating the pants off of the University of Michigan when it comes to studying all of this.
Oh, my goodness. It's the exact opposite. I would love to see Notre Dame put together a college of human performance, or just a department of human performance, so we could actually start studying these huge number of questions that are left unanswered. And I think Notre Dame could become an international destination for human performance research if they really, really felt like putting in the effort and the money and the time.
Well, if this interview goes viral, which has never happened before, but if it did, maybe this is the catalyst for all of that to start. You're going to be the person who turns it around. But maybe tell us just a little bit about the Human Energetics Laboratory. What goes on there? What else should we know about that?
Yeah, so it's a very odd laboratory, as Notre Dame research protocol people have told me. They don't know how to classify my lab because it's not standard. So basically, I measure a lot of metabolic rates, and I've got a couple of different machines that do that. And I have mobile units, so people could put this mask on that also is connected to this small, book-sized thing that actually is measuring your metabolic rate. And they could go off and run around campus, and I could be getting data live from my lab the whole time. So I can get real-time measures of how many calories they're burning with whatever activity is that they're doing, which is really cool. And so there's that. And there's also one that's dedicated to measuring your resting metabolic rate, which is the bare minimum amount of energy you expend laying down and doing nothing all day long. And so that's a little bit of a different setup that's more sensitive. But I also have thermal imaging cameras, which are a lot of fun to play with. And I use that to assess something called brown adipose tissue. So brown adipose tissue is a kind of fat that burns only to keep you warm. So hibernating bears right now in Alaska are sleeping in their caves, and they are burning this brown adipose tissue to stay warm, since they're not moving and they're not up and around and they're not awake. And human babies are born with brown adipose tissue along their chest and their back. And it used to be thought that once babies burned through that, we as adults never got it back. Turns out there's brown fat everywhere. And it could potentially be very important for addressing things like type 2 diabetes and even obesity, because it bumps up metabolic rate, and it also helps clear out cholesterol and glucose, blood sugar from your blood. So I've got that. I've got a body composition unit, which measures your muscle mass and your body fat. But the other part, I should have brought this up first, is I have bomb suits. This is how it'll go viral. Technically, it's the inner lining of bomb suits that the military use. So you've probably seen from movies those big, gigantic bomb suits people wear when they go to defuse a bomb. What you don't see is that underneath that, they're wearing a sweatsuit with this tubing that runs through it, which is connected to a pump and then connected to a thing of ice water. And it helps to keep them cool in that suit so they don't overheat. For me, it allows me to control cold stress people in my lab without them getting wet, and I can maintain a constant temperature with that ice reservoir. And so I use that to cold stress people to measure that brown adipose tissue activity. But it does mean I get to say I have bomb suits in my lab, which is always exciting. And then I have various things to measure glucose and cholesterol levels and whatnot in my lab as well.
That's fantastic. Well, there's so much interesting material to cover here. I don't want to steal your thunder from your Hesburgh lecture. So everybody, you got to show up to the Mara Auditorium at Gettysburg College for the lecture. We'll be sending out all kinds of information about this. But in the meantime, Cara, thank you for your time. You're a world traveler, and I know maybe even coming off of some jet lag still, I don't know. But thank you for your time and your enthusiasm for this subject matter. Most of all, thank you for coming to see us in Gettysburg. We're really looking forward to it.
Thank you both for the opportunity to do this little promo, and I'm super excited to come out and visit y'all.
All right.
Well, Cara, as a club, as Pat mentioned, we're at least the two of us now, knowing what you're going to cover, are very excited. So now it's our job to get that out to the general public and get as much interest and as much following as we can.
Awesome. Feel free. I can also send you my Twitter handle or things if you do social media bumps, because I've got all that since I co-host my own podcast. So I get it.
Excellent.
Good.
Go Irish, and see you soon.
Go Irish. See you in a month.
See ya.